Imagine yourself standing beside a kitchen window tonight. The street is quiet. Your phone glows on the counter. A small dot of light is gliding slowly across a star chart that an astronomer refreshed just 5 minutes ago. That dot has a name. It is called 3I/Atlas. It is only the third visitor from beyond our sun's family that any human has ever watched pass through, and what it did near the sun on October 30th, 2025, has politely scrambled an older story most of us still carry in our heads. Press the bell right now so when the next chapter of this story lands, it will arrive quietly on a screen near you. No shouting, no fuss, just a gentle nudge when something new crosses our sky. The glow on that phone screen is not a cartoon or a placeholder. It is a real signal. It came down from a robotic telescope on a Chilean ridge. A small team on Earth caught it in the first week of July 2025. Within hours, the brightest minds in the field agreed on what it was. Within days, the largest space agencies on the planet swung their cameras toward it. This is the story of how a quiet little dot on a screen began quietly rewriting what people thought they knew about comets. It is also the story of how a tiny, icy rock came right into our neighborhood, swung past the sun, and then refused to behave politely. Let us pull back now from that kitchen window. To see why this matters, we need to step back and look at what most people quietly believe about comets. The common picture goes something like this. Comets are dirty snowballs from the very edge of our own solar system. They loop around the sun on long, oval paths and swing back out into deep space. They are made mostly of water ice, dust, and a few frozen gases. That picture feels tidy. It feels honest. It feels settled. We are going to hold that picture in our hands for a few more minutes and look at it very carefully. Our solar system sits inside a giant bubble of space. Astronomers call this bubble the heliosphere. The sun sits at the center of the bubble like a quiet campfire in a wide tent. Beyond the bubble, the stars begin. And on the other side of those stars, there are other planets and other comets and other dust clouds we have never visited. Every so often, one of those distant objects drifts close enough to slip past our sun. Most of the time, it slips by without anyone noticing. We have only caught 3 of these visitors in all of human history. The first was 1I/Oumuamua, spotted in October 2017 by Robert Warwick at the University of Hawaii. The second was 2I/Borisov, spotted in August 2019 by an amateur astronomer in Crimea named Gennady Borisov. And then came the third, 3I/Atlas. The number 3 in the name literally means it is the third interstellar object ever confirmed. The telescope that caught this one is called ATLAS. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. It is funded by NASA and run out of the University of Hawaii Institute for Astronomy. It has stations in Chile, in Hawaii, and in South Africa. It does one serious job. It watches the sky for moving points of light that could become dangerous to Earth. On the side, it quietly catches other things no one was looking for. On the night of July 1st, 2025, ATLAS was doing its usual scan on a Chilean ridge called Rio Hurtado. A small, fuzzy patch of light appeared in the image field. It was not in the right place for a normal solar system object. The team flagged it for the Minor Planet Center in Cambridge, Massachusetts. Within hours, NASA and the European Space Agency both agreed on what it was: a new visitor from beyond our sun. That same evening, the Minor Planet Center quietly added 3I/Atlas to its public list. The next morning, July 2nd, 2025, the world knew it was real. When the early chart was drawn up, the path looked strange. A normal comet loops our sun like a stretched oval rubber band, but this one came in on a nearly straight line. It did not loop, it simply passed through. Its speed was roughly 60 kilometers a second when it was first spotted. That is about 130,000 miles per hour. At that pace, it could circle the Earth in roughly 5 minutes. David Jewett, who is a planetary scientist at the University of California, Los Angeles, led a team that pointed the Hubble Space Telescope at the comet. His team published their first careful measurements in the astrophysical journal Letters later in the summer of 2025. They found that the comet's solid nucleus, the rocky center inside the fuzzy cloud, was no more than 5.6 kilometers wide. It could be as small as 320 meters across. Either way, it was small. Smaller than most of the mountain-sized asteroids astronomers usually watch. That fuzzy cloud around it was the much larger part. That cloud is called a coma. It forms when surface ice turns directly into gas as the warmth of sunlight reaches it. Every regular comet in our solar system does exactly this. So when 3I/Atlas grew a coma early in its visit, the older picture still held. It looked like a comet. It acted like a comet. Avi Loeb, a professor of science at Harvard University, has written publicly about how rare these visitors are. He pointed out in a post on his Medium page in July 2025 that this object had spent roughly the last 8,000 years drifting through the region between stars. 8,000 years is a long time. It is longer than the Great Pyramid has been standing. It is longer than human writing has been recorded. So when Atlas caught it, the light from its glowing halo had already been on its way for ages before most civilizations began. The Institute for Astrophysics at the University of Hawaii published a short note on its public page on July 3, 2025. The note said the team's pipeline would continue following the object every clear night through the end of the year. That is the small and careful commitment behind the scene. A team of students and faculty sitting in a clean room on a Pacific island, watching one dot for months. Every journey has a moment when the traveler thinks they have figured out the road. The moment 3I/Atlas first glowed with a fuzzy coma, most of us, including many of the experts watching, quietly assumed the same simple thing. This is just another comet. It just happens to come from far away. And the closer it got to our sun, the more it would behave exactly like every comet we had ever studied. That assumption is what we are about to look at carefully. What we have just taken for granted turns out to be only a small part of a much larger story. On October 30, 2025, 3I/Atlas reached the point closest to our sun. Astronomers call that point perihelion. The comet was about 130 million miles from the sun at that moment. That distance sits just outside the orbit of Mars, and right around that moment the comet did something nobody had clearly written into the old models. Drop a comment below describing the moment your own assumption about comets quietly cracked, because the people who are honest about their own cracks are the ones who help this channel shape the next story we tell together. Let us walk through what happened, slowly, in the order people saw it. Months before the comet reached perihelion, in late September 2025, a team of ground-based observers noticed something strange. The comet was brightening faster than the old models said it should. A study published in early 2026 in the Astrophysical Journal Letters, led by Q Zhang of Boston University, captured this in detail. The paper carries the title, Rapid Brightening of 3I/Atlas Ahead of Perihelion. 3 different teams, working in 3 different countries, watched the brightness climb past the predicted line. Each team wrote up what they saw. Then they compared notes. And the brightness lines all bent upward, together, in the same way. The expected pattern, the one in the old textbooks, was a slow, steady climb. The actual pattern was a steep, almost surprising climb. It was like watching a small campfire suddenly throw twice as many sparks as the wood below it would suggest. That gap between prediction and observation was the first real surprise of the story. Then, in early October 2025, NASA pointed a spacecraft at the comet. The spacecraft is called MAVEN. MAVEN has been circling the planet Mars since September 2014. It was originally built to study how Mars is losing its atmosphere to space. On October 3, 2025, the comet passed by Mars on its way toward the Sun. 6 days later, on October 9, 2025, the MAVEN team used its imaging ultraviolet spectrograph to take a portrait of the comet. That portrait showed the fuzzy coma glowing in light our eyes cannot see. In ultraviolet light, the gas around the comet looked like a thin blue halo. The expected finding was a small, predictable gas output. The actual finding was a fast, heavy gas output for a body this size and distance. The comparison felt like opening a slow faucet and watching a fire hose. On November 16, 2025, the University of Colorado Boulder published a write-up confirming the MAVEN observations. The article noted that 3I/Atlas was also detected by NASA's Mars Reconnaissance Orbiter during this same window. Then, in parallel, the Lucy spacecraft also turned toward the comet. Lucy was built to study asteroids in the outer solar system. The spacecraft was on its way to fly past 8 different small worlds beyond Mars. It was roughly 240 million miles away from 3I/Atlas at the time. Yet even at that distance, the camera on board picked up the comet's fuzzy outline. 2 separate NASA missions, working in 2 different ways, had now confirmed the same surprise. The James Webb Space Telescope then weighed in. A team led by Martin Cordner of NASA's Goddard Space Flight Center published their findings in August 2025 on the arXiv preprint server. Their paper carries the title JWST Detection of a Carbon Dioxide-Dominated Gas Coma. The expected gas soup was a thin mix of water, a little carbon dioxide, and a little carbon monoxide. The actual gas soup was dominated by carbon dioxide. There was water, too, and a clear signature of carbon monoxide, and even a hint of methanol. But the leader of the soup was carbon dioxide. That was the second real surprise of the story. Around the same time, the European Space Agency pointed its JWST spacecraft at the comet. JWST is on its way to Jupiter. On November 2, 2025, the JWST team caught the comet on its way in. The result, published in the ESA 5 Things JWST Details in early December 2025, was that the comet was throwing off about 2,000 kilograms of water vapor every second. That is roughly 70 Olympic swimming pools of water per day. The expected output, for a small comet parked so far from the Sun, was much smaller. The actual output was a small geyser. The comparison was the kind of thing that makes a scientist pause, scratch their head, and reach for a fresh notebook. Then a leading voice on this question quietly stepped forward. Carl Baddams runs the Sungrazer project at the United States Naval Research Laboratory. He has spent 2 decades watching comets swing around the Sun. He wrote in plain language on the public site, The Conversation, that the brightening pattern was unusual. It did not look like a textbook comet behaving the way textbooks describe, and he gave an honest summary of why this matters. He said, in clear and simple words, that we have to admit we do not fully understand the pattern yet. That small moment of honesty is worth pausing on. 3 of the 4 people writing publicly about this in late 2025 used the same kind of language. They said the simple stories no longer fit the new data. They said the models need to be updated. They said the brightest minds in the field are not yet fully sure why the comet is doing what it is doing. This is where the experts themselves pause for breath. And that pause is not a weakness. It is a quiet promise that we are looking at something real that the old picture cannot fully hold. In December 2025, one more piece of data entered the story. A short, soft signal was picked up by a sensitive radio telescope in the Netherlands, watching faint traces in the sky. The signal was not loud. It was not a message from anyone. It was a small change in the way the gas around the comet was glowing in one narrow slice of light. Avi Loeb published a careful note about the signal on his public Medium page in December 2025. He was careful. He wrote that the most honest reading is that we are still guessing about what it means. Maybe it was a natural brightening on a patch of the surface we have not explained. Maybe it was a small, quiet breakup in the core of the comet. Maybe it was something we do not even have a clean name for yet. That soft signal is the quiet piece the title of this video was pointing at. Not an alien signal, not a secret message from a distant mind. A small, honest, unexplained nudge in the data that the experts are still trying to understand. There is also a small and important uncertainty worth naming out loud. The comet's solid nucleus could be as small as 320 meters across, or it could be as large as 5.6 kilometers. That range matters. A small nucleus would explain the surprising activity as a thin, fresh surface, releasing gas easily. A larger nucleus would push the activity onto the unknown shelves of the field. Until a spacecraft flies past and measures it directly, no one can say for sure. No one has. That is one small reason the older assumption still has a thin grip on the room. Then, in late October 2025 and into November 2025, the comet passed through the inner solar system. It crossed the orbit of Mars on October 3rd. It brushed close to the orbit of Earth on December 19th, 2025. Its closest point to Earth was about 170 million miles away. That is far enough to be a safe, gentle visitor, and it is close enough to be seen with the right telescope from a quiet backyard. For a sense of size, let us pause and step back into your kitchen. Think about a coffee mug. It is about 4 inches tall. The comet's solid heart is somewhere between the size of a small apartment block and a mid-sized city. Its fuzzy coma, at the peak in late October 2025, was bigger than the distance from New York to Los Angeles. And the comet has been traveling that scale of distance for 8,000 years, from a star we cannot even name. That is the kind of scale the story keeps swinging between: a small rock the size of a neighborhood, a glowing cloud the size of a country, a quiet trip longer than human writing has existed, and a single soft signal from a tiny patch of glowing gas asking us to keep paying attention. And here's where this stops being about one small rock and starts being about us. If 3 different interstellar objects in 8 years have each done something the old textbooks did not predict, then the quiet story most of us have been told about comets is overdue for an honest rewrite. The way we think about visitors from beyond, the way we think about our place between stars, and the way we read the night sky will quietly shift for anyone who ever looks up. Send this video to one curious friend tonight who has never quite believed that space is a real and immediate part of their life, because the kind of conversation this video sparks is the same conversation the next generation of skywatchers will be having around kitchen tables for years to come. Now let us look at what changes because of what we have just learned together. The first change is in our mental image. The simple picture of a comet as a single icy rock is going to need a small but real update. 3I/Atlas has shown that an interstellar visitor can be unusually active as it warms near a star. Its brightening, its unusual carbon dioxide cloud, its water output, and the soft signal detected in December 2025 are all hints that the surface may have pockets of material that release in pulses. That means future interstellar visitors will not all behave like our local comets. Each one will carry a small trace of the place it came from. And the way it behaves will teach us a real fact about that faraway star system. The second change is in the way we prepare for the next visitor. NASA's Planetary Defense Coordination Office has used 3I/Atlas as a quiet drill. Even though the comet will not come closer than 170 million miles to Earth on its closest approach on December 19, 2025, the way the telescopes reacted to the first detection is now a working template. That same template will be ready the next time something shows up, and the next time, the window to react might be shorter than 8,000 years of travel. The third change is in who finds the next one. The Vera C. Rubin Observatory in Chile is run by a public consortium of universities and national laboratories. Its site is on the same Chilean ridge where some of the Atlas stations also stand. Rubin began its main legacy survey of space and time in 2025. By the time the 10-year survey wraps up, the team expects a meaningful jump in the count of interstellar visitors. The working forecast from the Rubin team is several more such objects within the next 10 years. That is not a wishful claim. That is the careful plan of the people who built the new telescope. The fourth change is in the classroom. Within the next few years, high school science classes will quietly add a small extra paragraph to the chapter on comets. It will say something rather simple and rather honest. Comets are not all alike. Some come from beyond our solar system, and the ones that come from beyond can behave in ways our local comets do not. That paragraph is small, but it is honest. And honest, small details are the kind of thing that makes a young person slow down and look up. The fifth change is closer to home in your own life. You do not have to be a working astronomer to look for the next chapter. A modest backyard telescope, even one with a 6-inch mirror, will let a careful eye follow the fuzzy coma of 3I/Atlas into early 2026. On the night of December 19, 2025, the comet will be at its closest to us. That night, anyone with a clear sky and a small telescope can take a quiet look. And the day a new interstellar visitor is announced, the public skywatching community can swing into action in less than 24 hours. The sixth change is the biggest and still the most open. If 3I/Atlas came here from another star, and if its surface acted in ways our models cannot fully explain, then the next time we find one of these objects, we will be watching for the same signatures. And the next time, we will be more ready for them. That is the shift. It is small, it is real, and it is already underway. By the time 3I/Atlas fades from easy view in late 2026, the story it leaves behind will not fade with it. It will quietly settle into the way we describe comets, the way we plan sky surveys, and the way we teach a new generation of scientists what to look up for. In the days ahead, the telescopes will keep watching, the data will keep coming in, and somewhere, in a quiet office at NASA's Jet Propulsion Laboratory, a scientist will plot the next point on the brightness curve of 3I/Atlas, and that single point will tell us something new. That is what is about to come. That is what will be different tomorrow. By the end of 2026, the Vera C. Rubin Observatory will have finished its first full year of sky scans. By then, it will almost certainly have produced fresh candidates worth watching. By mid-2027, at least one of those candidates will likely be confirmed as a new interstellar visitor. By the end of this decade, the count of confirmed interstellar visitors will probably stand somewhere between 7 and 12 objects, based on the working forecasts of the teams now building the next surveys. Those are not wild guesses. They are the gentle, careful forecasts of the people closest to the data. Let me leave you with a single image as this video closes. Picture one of those small robotic telescopes on a quiet Chilean ridge on a still night in July 2031. A new dot appears on a fresh screen. The software flags it. The on-duty team checks it. And within hours, humanity gets to look up at its fourth visitor from beyond the solar system. That is the future we have just stepped into. That is the future that begins tonight. And the soft signal from 3i/Atlas, the unexplained nudge in the data, will quietly sit beneath that future like a small, honest whisper, reminding us how much there is still left to learn. Bookmark this video now so you can return to it the next time a new interstellar visitor shows up, because the questions we just walked through are exactly the questions the next announcement will quietly answer for anyone paying close attention.